Good morning, everybody, and welcome to the DevNation Tech Talks. Today, we're going to be doing something called Getting GitOps, which is going to be a fantastic overlook at the kind of concepts and technologies that we currently have and are forthcoming on the OpenShift GitOps side. I'm very happy to have Harriet Lawrence with me, who is our go-to person for GitOps. She's currently the product manager for the OpenShift GitOps side. And I'm looking forward to some seriously cool stuff today. So hiya, Harriet. Welcome to the show.
Thank you so much. I feel very welcome. Thank you, everyone, for attending today. I will give us a little overview of the agenda, and then we will jump straight into our talks. So if we could get the slideshow going, that would be awesome. All right. So first up, we are going to have a look at Red Hat OpenShift GitOps, what's happening in our upstream community, Argo CD, and what features are coming soon. That's with me and one of our amazing technical team leads, Abhishek. So after that, I'll be showing you around our validated patterns, and we'll have a demo of the multi-cloud GitOps pattern. We've got 3 of our OpenShift customers with us today to tell us about how they're using OpenShift GitOps and OpenShift pipelines in their CI/CD workflows. So we'll hear from Philip at PostNord Stralfors, Richard and Micho from Arbeits for Medlingen, and then Thomas and Manuel from Swiss Railways. To wrap up our time together, we've got an AMA session with some folks from Red Hat. That's with Abhishek and myself, Ian, who you just met, Christian, one of our PMs for Red Hat Advanced Cluster Manager, and Natale, one of our developer advocates. All right, if you have any questions during the event, do put it in chat, and that will come straight through to all the presenters, and we'll be able to get back to you. Cool, so let's get going. We'll start off with our Red Hat roadmap and Argo upstream. Great, if we could get Abhishek's video on as well, that would be great. All right, so what's on today? What are we going to cover? We're going to look at a little quick intro to GitOps and GitOps workflows for anyone who's new to the topic. We're going to have a look at the Argo project and Argo CD, which is our upstream. And then we'll have a look at what the OpenShift GitOps product is. And finally, we'll do some more resources that you can kind of follow up with afterwards. All right, and I will pass over to Abhishek. Give us an overview of GitOps. Oh no, we've lost Abhishek. That's okay. I think we're having some technical trouble on our end. Just give us a moment and we will figure it out. Abhishek's returned. Hello. We'll see how we go. And if we can't sort it out, I can take over while we figure it out.
Oh, yes, Ardit, please go ahead. Hey, everyone.
This is Natale.
Hey, nice to see you. It looks like we're having some technical issue with Abhishek. If you can take his part.
No worries at all.
Then we can.
Okie dokie. So we'll have a little overview of GitOps. So what is GitOps? So GitOps kind of came out of DevOps. It took the DevOps lifecycle, tied it into Git, and it kind of added in continuous reconciliation. So it's mostly focused on the continuous deployment and delivery part of the DevOps lifecycle. But GitOps also brings in elements of continuous monitoring, infrastructure as code, as well as the kind of cultural aspects of collaboration and communication. So we start off here on the left with treating everything as code. So that's the entire state of the infrastructure, the applications, configurations, that's all defined declaratively. So that includes what the infrastructure looks like, how the application should be deployed, how it should be configured across different environments, and even your CI/CD infrastructure itself can and should be treated as code. So this can be quite a different way of working to what folks are used to, but there are a lot of benefits to that, which we'll cover in a minute. So in the middle here, we've got Git as a single source of truth. So when you've got everything as code, you need somewhere to store it. And that place is Git. So this gives you a single source of truth via Git's version control system. And that gives you the traceability and visibility that you get from using Git like you're familiar with in your code. And any change that's made to infrastructure or applications is first represented declaratively in your Git repo. Finally, we can extend this setup to our kind of day-to-day ops. We can do our provisioning and our deployment through our familiar Git pull request workflows. And one of the core ideas of GitOps is that we can take that same workflow that all our developers are used to from managing code and utilize it for any change that's made to our infrastructure and our applications. All right, so these are the 4 core GitOps principles. And these were defined by the GitOps working group in 2021. These aren't like enforced or anything like that. It's just kind of the guiding principles. So the first is that your system is described declaratively. And that means that you've written down somewhere, usually in YAML, what your system should look like, be that an application with access controls or how a cluster should be configured. Secondly, we want this desired state to be versioned and immutable. So we need our YAML files to be stored somewhere that's central and accessible, and that will create the single source of truth for our system. And this usually comes about by using Git, but any system that complies with this principle can be used. So next, we want any changes that we approve to be applied automatically. So usually the approval process is via a pull request to your config repo. And once that merges, we want those changes to be rolled out automatically. So not only does it pull from Git, but it also polls at regular intervals to check for changes, which leads us to the last one, which I feel is the real key part of GitOps. So you've got a controller that monitors your repo, polls for changes, and then it detects drift between your desired state and the actual state of your system, and it can act on that drift. So this could be notifying you of the discrepancy, or it could be automatically bringing it back into sync. So we kind of touched on all 4 of these, kind of why GitOps on the last couple of slides, but they do bear repeating. So you get so many different types of benefits from using GitOps workflows, from your developer team being familiar with the tooling, to your security team being able to get in and be an active part of the development and deployment process. Get the start of a DevSecOps framework effectively for free alongside your deployment workflows. Your compliance team members can implement their policies as code, and then they get a Git history available as their audit trail. Then we've got the scaling benefits. So deploying replicas, keeping them in sync. It's as easy as changing a single number in a YAML file. So deploying to all your different clusters in different clouds with different parameters, different infrastructures can all happen from the same place and all in YAML. Reducing it down to a single language and place to manage, no matter how many clouds you're using, reduces your maintenance and training overheads and reduces the knowledge silos across your org. So that was a whirlwind introduction to GitOps. We'll have a little look at the Argo project and Argo CD. So as you're all probably well aware, Red Hat is very active in the open source community, and the Argo community is a very active place. So Argo is the upstream of our OpenShift GitOps product. it's not just Argo CD. The Argo community is broader than that. It's the whole Argo project, and they've got a lot of different products in there, or open source products. So there's Argo CD, Argo rollouts, workflows, events, and they've also got an Argo Proj Labs as well, which is kind of helps to incubate new and interesting ideas and give them a space where they can mature a bit before they make it into the Argo Proj core. This is a really very active community. There are a lot of maintainers and contributors, and our OpenShift GitOps team is really active in the upstream as well, which is really awesome. We've got at least one core maintainer, we've got a bunch of reviewers, and all of our engineers contribute to the code base. So originally, Argo was created by Intuit, but it's not just kind of community individuals who maintain the software. There's all of these kind of corporate contributors as well. So Red Hat's one of the ones there, and we work closely with the other corporate contributors to kind of help push the community along. We give them engineering resources. We can share the benefit of our kind of organizational knowledge with the community to help them along. All right, so a little bit about Argo CD. So that's our upstream project. And very excitingly, it recently graduated from the CNCF. So that, I think it was the 20th project to graduate. So that was very exciting. That happened at the end of last year. So here we've got an overview of its key features. It does versioning and Git for both cluster and app config. We've got automatic sync from Git to your clusters, the drift detection that I mentioned earlier between desired and actual state, and it visualizes this drift as health in the Argo CD dashboard, and provides the ability to self-heal the drift as well. You can choose your sync order if you've got a deployment that needs to happen in a specific order. And as Argo CD is based in YAML and stored in Git, you can roll backwards and forwards based on Git commits. You can use any manifest templating that you need. There's built-in support for Helm and Customize, but also the ability to load in custom templating via plugins. And lastly, the dashboard provides you with some visual insight into your sync status and history. So this is what the dashboard looks like if you're unfamiliar with Argo. So you get this through the Argo CD dashboard, but you can also see your development history, your deployment history, and environments in the OpenShift console as well. Great, so there's some exciting things coming from Argo Upstream. The 2.7 release is currently under development, and we're expecting that to release in a couple of months because they have just released 2.6. This 2.7 release has some very exciting things coming out in it. So we've got the multiple sources general availability. So that's been available as a beta or tech preview. And that lets you support more than one source when you create an application. Multi-tenancy GA. So we've been doing, the Argo community as a whole has been doing a lot of kind of incremental improvements into multi-tenancy. And one of the big ones that went out with, I believe, 2.5 was the ability for Argo CD applications to run in any namespace. And that's going GA with the 2.7 release as well. So that's very exciting. We've also got advanced templating coming out soon for application sets. So you can already do a lot of templating with applications, but this is quite new to application sets. All right, so let's have a look at how this translates to OpenShift GitOps. All right. Okay, so this is our this should be fairly familiar to all of you. This is a general kind of CI/CD development workflow. And this is where our Red Hat official operators fit in. So we've got OpenShift GitOps for the CI/CD part of it, and OpenShift builds and OpenShift pipelines takes over the CI part of it. So what is OpenShift GitOps? At its core, it's a Kubernetes operator, so a package of custom resource definitions and based on Argo CD. So we also provide access to the Argo CD UI directly from the OpenShift console to manage and monitor your deployments. You get multi-cluster management. So as I mentioned before, it can manage cluster and application configuration. It can do that for multiple clusters from one place. And one of the most exciting features that recently went GA is application sets. So that lets you automatically generate applications. So from a single YAML file, you can describe your application, list all the clusters you'd like it deployed to, and Argo CD will take care of creating them all at the same time, across as many clusters as you specified. So there's lots more that you can do with application sets. Creating and managing replicas is just one example and one that I'm particularly excited about. So we've also got automated install and upgrade of Argo CD. So when you install GitOps through the operator hub in OpenShift, it'll give you an instance of Argo CD that's all configured and ready to use. And you can choose to automate your upgrades as well. So the operator lifecycle manager, OLM, will ensure that you're always on the latest version. And that'll include the newest features and any relevant security updates as well. OpenShift GitOps takes advantage of the built-in OpenShift OAuth server for our SSO configuration. So Argo CD ships with support for DEX and Keycloak, but in the GitOps operator, DEX is able to understand the OpenShift groups and users. And if you're using Keycloak, it can act as a broker between Argo CD and OpenShift, allowing you to log into the Argo CD dashboard with your OpenShift credentials. And finally, we've got deployments and environments insights. So GitOps is integrated with the OpenShift console. If you're familiar with OpenShift, you're probably used to working in the developer and admin consoles already. And this is where you can find your GitOps applications as well. So you can see all your environments, you can filter by project, and you can see your deployment history in there alongside everything else in the console. All right, so how are our customers using GitOps in their environments? Everyone I talk to is doing things slightly differently, which I think really highlights the flexibility of GitOps and Argo CD. So some folks are doing purely application delivery, and this is probably the use case I see most often. And I think a lot of folks assume from hearing the name Argo CD, the continuous delivery part of it. So one setup that I saw had Argo managing 18,000 applications across 4 different environments. So they had like dev, test, stage, prod, something similar to that. They were running 3 instances of Argo CD and using attribute-based access control to manage their teams and users' access to their applications. So other folks are using it to configure their clusters. So using application sets to declaratively define cluster config and then stamp out as many as they need. I've seen a single instance of Argo CD on a hub cluster, managing config for all the spokes. I've also seen folks with Argo CD per cluster, managing just the config for that cluster. So this kind of blends a little with the multi-cluster management piece. You can totally use Argo CD to manage just a single cluster's config, but more and more often these days, folks are running tens or even hundreds of clusters, and that quickly becomes a pain to manage by hand. So for these last 2, we'll hop over to the next slide and I can talk about different arrangements of Argo CD instances and how they work with permissions and such. So these are 3 different deployment strategies for Argo CD instances. And each one of these is a totally reasonable way of doing things. I've seen people using each one of these very successfully in prod. And whenever people ask what is the best way to set up Argo CD, I always have to say it depends, and then ask a bunch of questions. So things like how your dev team is structured and what access requirements do they have? What is your organization's threat model? Who's going to be managing the instances? And are those people different from who will be using the applications and interface day to day? So once you've got answers to questions like these and you've got a good understanding of what your requirements are, then you can kind of come back to this slide, and one of these will make more sense to you than the others. So if we have a quick look at each one, I understand that we're running a little bit behind schedule. So with the central hub model on the left, you've got one Argo CD instance based in your OpenShift hub cluster. And this pushes configuration out onto remote OpenShift or Kubernetes clusters. So this is a really nice way to get started. It provides you a single place to administer, but it does mean that you'll need some elevated permissions to push out to those other clusters. So for those with higher security requirements, the cluster scoped model in the middle might suit you better. So the Argo CD instance sits inside the same cluster that it's modifying. So you can have as many clusters with their own Argo CD instances as you need, and they don't need to store any access credentials because they are already in the cluster itself. So either one of these are great for multi-cluster management. If you're looking for a more fine-grained access control than those two provide, you could look at the one on the right, the application scoped model. So this is more into the multi-tenant application management area. So we've got multiple Argo CD instances inside a single cluster, and they can each manage a single application if you like. They can pull config from different configuration repos, and that enables you to kind of divide up your access permissions even further. So as I was just mentioning with the applications and in namespace, this is a really awesome feature that our engineering team added to upstream. So instead of just being able to have your applications in the control plane namespace, you can specify a list of namespaces that you want Argo CD to scan for applications and manage. All right, so what have we been up to and what's coming soon? So the one I was just talking about is a recently released feature. So this came out with our most recent version, 1.7, and it is available as a tech preview. Argo CD can recognize the application resources that have been applied across the cluster, not just the namespace where it's been deployed. And once you've given it the list of namespaces to manage, it keeps them all in sync for you. Server-side apply is a really exciting one as well. So Argo CD added support for Kubernetes improved version of kube control apply, which is server-side apply. And that's kind of if multiple users are trying to manage the same field, the same resource, server-side apply provides like a conflict management capability. So it can force an overwrite or seed claim to a field. So you can use this to store just like a segment of a CR in Git, and like that would describe just the piece that you want to change of a resource. Perhaps that resource is something that gets automatically created by OpenShift. And Argo CD can then apply your patch and then monitor that resource for changes and keep it in sync with your desired patch state, which is pretty cool. And also recently, we had our first foray into the world of multi-arch, and we added support for running on IBM Power and Z systems. On the coming soon side, we've got Image Updater as tech preview. That'll be out with our next version, which is coming very soon, a couple of weeks, I believe. So when you're building your images in your CI pipeline, it's kind of a pain to have to then go and update your Kubernetes manifests, new tags, digests for the image. Image Updater gives you the ability to auto-update the manifest once a new image is available. Support, this one's pretty self-explanatory, still exciting. Multi-tenancy guide. So our developers and our docs writers have been collaborating on a big new piece of documentation. It's a guide to how permissions and multi-tenancy work in OpenShift GitOps and how to utilize the features that are available to create the access control that you need. Progressive delivery. So I bet a bunch of you will be excited about this as well. We will soon be offering a properly supported tech preview of Argo rollouts in the GitOps operator. So Argo rollouts, as you saw before, it's a whole separate code base, Argo CD. So unfortunately, we can't just flip on support for it like we could for a feature. Argo rollouts is, it kind of provides the ability to do more advanced deployment scenarios like blue-green deploys, canary deploys. And we'll be looking at integrating that with OpenShift Service Mesh to do traffic management. And we'll be looking at how we might be able to incorporate the rollouts UI into the OpenShift console as well. Okay, and finally, we've got Secrets Manager support. So this one is a little bit more fuzzy at the moment. So we'd love to add a kind of native integration for folks to use Secrets Managers with OpenShift GitOps. And we're looking at several different ways of going about this, but we know that secrets management is really important and really important to our customers. And we want to make sure that we're making it as easy as possible for you to use your choice of Secrets Manager. So if you've got strong requirements around how you need to use secrets, get in touch. I would love to chat with you about it. All right, and finally, I've added some resources in here, and we'll be sharing these slides after the session, so you can come and grab the links. So we've got a brand new shiny page on OpenShift GitOps. We've got a couple of really awesome books. So there's The Path to GitOps by Christian Hernandez and the recently released GitOps Cookbook by our very own Natalia Vinto, who you met earlier. And if you're looking for something a little bit more hands-on, we've got the Cube by Example Introduction to Argo CD tutorials and the Red Hat Developer Learning Path on GitOps. All right, thank you very much. Okay, I'll have like a brief break.
Hey, Jorge, that would be that is great. Thank you for this great introduction of all such amazing topic. And I think we have Abhishek also with us. So I take this opportunity to say
Abhishek.
hi.
Hi. Yeah, am I audible now?
Yes, we can hear you. It's wonderful.
Yes.
Yeah. Okay. Yeah, I'm so sorry for that. Thanks a lot, Harriet, for taking it from there. Yeah.
No problem. And I wanted to know, Arya, that we had a little problem in the chat before. So I'm asking to the folks to, if you don't see the chat, please refresh the browser to see the chat. You should be able to see the chat. It's important so you can send a question to Arya and all the people. We're already some question here, and we will take all the question and to the end of the session for the Ask Me Anything. But yeah, other than that, great press or great intro, Orient.
Thank you very much.
And good to see you, Abhishek. Do you want to add something more about what
Harriet? No, I think Harriet has covered it pretty well. Yeah,
and if anyone's got questions about any of that, Abhishek and I will be back later in the AMA, and you can ask us as many questions as you like about it then.
Sounds great. Thank you.
Awesome. Okie doke. So you get me again for the next session. I promise that will be the last you'll have to hear my voice for a little while. So next up, we have got an introduction to validated patterns. All right, I will share my screen. It's going. All right. All right, Natalia, if you could add my screen share into stream. It's always exciting doing things live and trying to make technology work. Okie doke. Great. So what are we going to talk about today? We have got validated patterns. What are they? We're going to have a look at the multi-cloud pattern and a little demo, which is very exciting. And then we'll have a look on where we can find more information about these patterns as well. Okay, validated patterns. Great, so Red Hat's validated patterns are their repositories and documentation, and they show a use case in the form of Helm charts, and they describe a hybrid cloud stack and edge computing and how to do it declaratively and comprehensively. So this covers everything from services all the way down to the supporting infrastructure. And these patterns facilitate complex and highly reproducible deployments. And they're ready to be used, and they're ideal for operating deployments at scale using GitOps practices. So they're also not like kind of ye old reference architectures that don't end up showing you much in the way of specifics. They're repositories full of code that are ready to go. And the team behind these patterns at Red Hat has put a lot of work into making them lightweight, easy to install, and easy to get running. Great, so these are all of the published patterns, and they're available right now, and they're being added to all of the time. So there are several more that are being proposed, but these are the ones that are on the GitHub already. So the symbols in the top right will tell you where the community patterns have like a partner or a customer working with us directly on that pattern. So the community list that we've got on the left is patterns, but it's also some sub-patterns or partner products that can be kind of interchanged into our other patterns. So for example, Cockroach DB can be used in one of the validated patterns if a database is needed. The main one that we're going to look at today is the third one down on the validated list, multi-cloud GitOps. But before we get onto that, another one that I'd like to draw your attention to is the third one down on the community list. And that is multi-cluster DevSecOps. So that one's pretty new and it's awesome, and you should all go check it out afterwards. So there is a kind of reasoning behind splitting the two categories, the validated and community. And the main difference between these groups is the maintenance cycle of the patterns, but there are some other differences as well. Cool, so the validated patterns, they are maintained in a life cycle. So they are periodically reviewed and they have like a CI pipeline at Red Hat associated with them and can be tested with newer product versions. They include a demo that demonstrates the use case for the pattern. And they're designed in a really modular fashion. So individual functions can be replaced, like I mentioned with Cockroach DB. They're all built on GitOps, which is wonderful. And the validated patterns all require 3 or more Red Hat products being used together. The community patterns are also very modular, but they're designed to demonstrate a really specific capability that could be applicable across use cases. So some of these patterns are created by Red Hat, but we've also got contributions from other customers and partners as well. And then this is where the maintenance cycle kind of differs from the validated patterns. Community patterns are tested when they're created, but aren't retested over time with newer versions. Okay, so that's a little bit about validated patterns generally. Let's have a look at some specifics. So multi-cloud GitOps pattern, what is involved in that? Okay, so I've grabbed these two lists from the validated patterns website, where each one of these patterns is documented in detail. They've got lots of instructions, there's links to all the repos, and absolutely everything you need. So the main parts of this solution, we're going to use GitOps workflows to manage a bunch of deployments across clouds, be that public or private. We'll be able to centrally manage all of our clusters and workloads. And we're going to be able to manage our secrets securely. The things that we're going to use to make this happen are the OpenShift Container Platform, OCP, our Red Hat Advanced Cluster Management, that's ACM, OpenShift GitOps, obviously, and then we're going to be storing our secrets in HashiCorp Vault. So how does this all come together? So this is quite a busy slide, but we can break it down a bit. On the left-hand side, we've got a cluster, and that acts as our management hub. So this holds our cluster management tooling, which is the ACM control plane. GitOps hooks into ACM and will perform the continuous deployment. And our Vault lives in here as well. So that could be any secrets manager, but in this pattern, we're using Vault. On the right-hand side of the slide are the clusters that ACM manages. So you can have as many of these as you need. They can be replicas or they can be entirely different from each other. The managed clusters hold your deployed applications, and any secrets that you require get passed into the clusters from your Vault. All right, hopefully that hasn't been too much information all at once. Let's have a look at a demo of what it's like to set up this pattern on some real clusters. Stop sharing this one and I will share my whole screen. You get to see my terminal. We'll do some looking at codes. All right. Share entire screen. There we go. Should we get? Okie doke. So let's get rid of our slides for the minute and we'll have a look at what we need here. Okie doke. So we've got, to start with, we've just got the repo from GitHub, the multi-cloud GitOps repo that our validated patterns team has put together from us. I just cloned that and I haven't changed anything. We've got a heap of stuff in here, but we don't have to worry about most of it to get started. So we're on our main branch and let's have a look. Where did we start here? You can see all the behind the scenes setup. Okay, doke. Great. So the main important things that you'll be concerned with is this pattern.sh file. So this is pretty much the only command you need to run, and it will go and do all of the magic for you. The bits that are kind of most interesting for you are going to be, where are we finding them? Cluster groups, values. Let's find our values files. Values hub. Could have been more organized with my files. Values hub, YAML. Where did you go? Values global. Oh, they're right there. Great. So we've got this nice little values global file, which will tell us a little bit about what we're up to. We've got one for our hub. And this is where we declare what we want deployed. This is where we'd add more applications if we needed more things to be deployed onto our hub or to our clusters. So we define all the different namespaces that we want here. We say that we want ACM. We can define OpenShift projects. And then this here is our applications. And this is each of the things that it's going to deploy for us. So we'll get ACM, we'll get Vault, we'll get external secrets, and then a couple of little demos as well. So config demo application and hello world. So this is like probably the coolest part is you can just add more things to the applications section, add a new namespace for it, and it will take care of all the rest of it for you. So we've got, that's the hub cluster, like we saw over here, that's this one. And our managed cluster that we've got, that is values group 1. We've been creative with our naming. So this one is a little bit different. We don't need ACM. We're just going to have external secrets and our 2 demo apps as well. Cool. So this one is going to be our edge cluster for the purposes of this demo. All right. You can add, if you've got like a bunch of different types of clusters, you want to have like a couple of very different edge clusters. You've got different requirements. You've got different clouds. You can just add multiple values files, one that describes each type of cluster that you want to do. If you want to have the same cluster be kind of replicated, all you need to do is import your cluster into ACM and give it the label of group 1, and it will know that it can come and look at this and say, I already know what that cluster should look like, and go and add all those applications to it, which is super cool. All right, so what did I do to make this go? I ran pattern make install, and that was it. This went and did a heap of different things for me. I didn't want to do this live because it does take a little bit of time. So if we have a look through, we had some nice little waiting for Vault. So this will just kind of monitor and wait for all of the background stuff that's going on. And once our Vault was ready, it kept going. So all of our setup, that's really nice. Good, good, good. We had pretty much empty clusters before this. And then afterwards, after this is run, we come into our OpenShift local cluster and we can have a look. So I've gone into operators, installed operators, and look at all these things. It's installed all this stuff for us. So the validated patterns operator is something that the team has made to go and install everything else for us. It's just a nice little helper tool for us. And it's got a bunch of stuff in it that is really awesome, and it will kind of set the stage for us, which is really nice. All right, so let's have a look. What else have we got in here? We have got, oh, and I wanted to tell you about Vault as well before we move on. So the, okay, good. The Vault install that we've got is using HA. So we didn't want to have problems with Vault going down and then not being able to unseal it again. So if there is any kind of problems, this setup has made sure that if Vault goes down, it will be able to unseal it again and you won't run into problems with that. So that's really nice. All right, so let's have a look. What have we got here? If we go back to home, this is what you're probably familiar with OpenShift console. And we can have a look into what we've got here. So let's close this one. We'll close this one. All right, so before we move on, installed operators. So ACM has not just installed itself, but also the multi-cluster engine for Kubernetes. So if you're installing things if you're like managing clusters directly from ACM, this is the thing that actually takes over and does the deployments for you. So that's really handy. But we've also got OpenShift GitOps all ready to go. Cool, so let us see if we can add some.
Hey, Harriet, we had a comment in the chat. If you can please increase the font
great.
size for terminal or browser. Thank you. I
can do both. How's that looking? More? Less?
Sounds great.
Okay, and we'll do, I don't think we'll be back in the terminal, but let's have that bigger as well. Thank you for pointing that out. I should have done that before we started. Okay, great. So let's have a look at, if we go to all clusters, we haven't just got those operators installed. We also got a bunch of other really cool stuff. One of the things that this pattern includes is policies. So ACM has this amazing governance feature where you can define these policies. And so this one, the OpenShift GitOps policy, that will go and make sure that OpenShift GitOps is installed on the cluster. And if it's not, you'll get a violation. And if you've got it in if it's enforcing instead of just notifying, it will go and fix it for you. So if OpenShift GitOps wasn't installed, this policy would make sure that it was. You've got a couple of other policies on here. So one for our edge cluster and one for our hub cluster as well, to make sure we've got the things that we need. Great, so in our clusters, we can go and add our second cluster. So let's import a cluster. All right, so this name here, it doesn't need to like match anything. This is just the identifier that ACM will use in the UI. So let's call that our edge cluster. we will choose our default cluster set. And we want to have our, so this is our group 1. So that is the important part here. We want it to be called group 1 to match the values file that we've given it that it knows about. So we want cluster group equals group 1. All right. And we are going to go and grab our kubeconfig. So I will just grab that off my desktop. Let's have a look. Kubeconfig. Desktop or region. And we'll pop that into here. Okie doke. We don't need to do any automation. Let's, oh good. It's not really a demo if we haven't had an error, is it? Let's go back. Probably did a little problem with my kubeconfig. Maybe my name, edge cluster. Hey, there we go. All right, so that was a cluster that was already spun up in the background. You can just create them, but I already had that one going, and so that we could just import it and have a look at what happens. So once that one comes in, we can go back over to our governance. It might take a little bit of time to actually do the import for us. But you can see now we've got one cluster with unknown status. So while that's spinning up, it's kind of evaluating these policies already and saying like, oh, do I need to do anything for those? While we're waiting for that to go, we can have a look over here. So we've got connections into our Argo CDs that have been set up for us. We can have a look at the hub cluster. Got a good privacy error. That's all right. Come into Argo CD, log in. Ugh. Give me my login details. We can watch this while we're waiting. Got, still thinking about it. Not that one, not that one. We want clusters. All right, ooh, there we go, we're refreshed. Let's go back to our clusters, look at our governance. 2 violations, there we go. It knows it's got a problem. So because we've chosen to enforce, it's going to go away and enforce that for us. And when we come back, we'll be able to see what's going on. Okay. So in this Argo, we've got all this stuff already. So this Argo CD instance has gone to that values file, that values hub file that we looked at already. So that is this one here. And each of these things, each of these applications that we defined has shown up here for us, and they're all nice and healthy. So that's pretty awesome. So how is that going to be different to the other one? If we go into the cluster Argo CD, we can have a look. And we'll log in again. Allow. All right, and then we've got our multi-cloud GitOps hub. So this is pretty cool. So this, the kind of hub Argo CD, this is like all of the kind of meta stuff that you're not going to need on like a day-to-day basis. This is like the management side of things. But in the cluster-specific Argo, if we go into this, we can see all of the stuff that it's gone and deployed for us. So this is like the config demo and our Hello World demo and all that cool stuff and all the things that it needed for those. Whereas in our hub, we've got like everything that we needed to install for ACM so that it could work. So they're quite different. And there is like so much involved in these things that it's so handy to have this pattern all ready to go that will set all this stuff up for you. And if we were to change anything in that values file, if I was, for example, to add a new application here to either the hub or group one, I could just commit this to my Git repo, push it up, and Argo CD in its infinite monitoring will watch for that, find that new addition. It'll see that it's out of sync, that it should have something in here that it's missing, and it will go and create that new application as well. Great, and now that we come back, look at that. It has gone and fixed our cluster violations. So all of our policies are now enforced and it's all happy and ready to go. Great, so if we come back to our original talk, I think we've only got a couple more slides. We've got where to find some more information. So I'll just keep sharing my whole screen. There are a lot of resources available for validated patterns. So I believe Natalia's already shared one of the websites in the chat, but there's also the GitHub where you can go and browse all of the code for all the different patterns. There's lots of patterns on the validated patterns site and the community pattern site as well. If you'd like to contribute a pattern, we would love to hear from you. We'd love to work with you and help you get that done. There's a bunch of blogs available that you can read about the new patterns as they come out. And there are a variety of demos available on YouTube that you can have a watch of. All right, and that's all I've got for you on validated patterns today. Thank you for watching my demo. That was very exciting. Sharing my screen.
Wow, that is a live demo. You use some captions saying live demo, live demo. It's impressive. Congrats, Oriet. I'm really impressed of this very well articulated multi-cloud, multi-cluster live demo. Impressive. So how the folks can reproduce this demo? Just going into the validated pattern and set up everything like you did?
Yep. All you need to do is fork the repo, clone it, and you can do exactly the same thing as I did. If you've got some clusters ready to go, you can just connect them up, and it's like magic.
Awesome. I'm sure Uth is doing that now, right? Uth, where it gone? I cannot see him. I'm sure. Oh, here we are. Hey, Uth.
Sorry.
I know you are trying this demo now.
I was busy enjoying myself answering questions on YouTube as well as trying the demo right now.
Wonderful. All right, so that's certainly enough of my voice for now. Next up, we have got Philip from PostNord. So over to you, Philip.
Yeah.
Hello. Let's see. Share my screen. See if I can do that without my computer crashing.
I think we saw your slides now.
Sometimes Restream likes to do a little crash.
Yes,
Yes,
we,
we
Yeah.
we can hear you.
Do you still hear me? Seems my browser window
it will come
crashed.
back.
See
I
if I
had
can reload
exactly the same problem.
it. Okay.
Hey, in the while, Philip or Artie, do you want to introduce Philip?
Yes, absolutely. So this is Philip Jensen. He is one of the engineers at PostNord Stralfors, and he will be talking about how they're using GitOps at PostNord in a minute, as soon as he gets back onto the platform. In the meantime, you can chat with Natalia and I.
Yes. If you have any question, please send the question in the chat. Alright, we already have some questions. Some are very interesting. Somebody mentioned hypershift with multi-pattern. So are we bringing all those cool questions to the end of the session? Because there are already some really great questions.
Oh, we can answer as we go. We can have them all in the AMA whenever we've got time for them, really.
Yeah, I think Philip. I don't see Philip. If Philip come back, we can restart sharing. But there was a question that was really interested to me. So Eric was saying, our developer currently use Ansible to deploy OpenShift and application like ClickHouse across multiple clusters. What advantage would Argo CD GitOps have compared to Ansible and what they have?
Yeah, so Ansible is awesome. Definitely a great choice using Ansible. I think that you do get like a lot of different things with Ansible, so it can kind of reach out and control things in lots of different systems. OpenShift GitOps is really integrated with OpenShift. It's like very deeply integrated. It's one of the layered products that comes standard as part of OCP. So the major advantage to using OpenShift GitOps is like it is the engine underneath ACM, and it links in very nicely with the rest of OpenShift, while Ansible is kind of a separate product. So there is a lot of overlap between like the way that you do things with GitOps and Ansible. It just depends on how much integration you need with OpenShift.
Sounds great. We have another question from Jonathan. Great session. Everyone in the chat is saying great session. Everyone is really happy with your session, Orit. You did a great job. But he has a question. Jonathan, is the image uploader already available? And Customize is also supported?
Yes, Customize is definitely supported. And I believe Image Updater is available in Argo CD upstream because they've just released the 2.6 version. OpenShift GitOps usually lags a couple of weeks behind because we run some extra tests. We want to make sure that it's going to be really stable for our different OpenShift versions. And then we won't ever release before an Argo CD version. We want to make sure we've got the latest before we release our OpenShift GitOps. So 2.6 will be in 1.8 of OpenShift GitOps. So you will see that soon.
Great. I don't see Philip coming. So maybe we have time for another question, then we move on. What do you think?
Yeah, we'll give him a couple more minutes.
Yeah, so there's another, there was another question. This is also interesting to me. Can this validated pattern use with hypershift? So our control planes version, let's say.
Ooh, I would imagine so. I'm still quite new to the multi-cloud GitOps pattern.
I think it will. Yeah, it definitely will, because what we've got with the hypershift is the ability to run multiple clusters within a cluster. So you have basically a hosted control plane. So at the end of the day, it's just a referenceable cluster. So Argo CD can actually target that in the same way it can target a standard cluster.
Very cool. I think ACM currently has tech preview support for hypershift. And getting inside information from behind the scenes for this. Oh, Philip's back. Welcome.
Thank you. I have switched computers. Let's see if this worked better. Just give me a minute to bring up my presentation.
Thank you. Just to close on this question, was really cool. So Christian Stark, who joined also later in the show, is confirming that Advanced Cluster Manager for Kubernetes as tech preview for Hypershift. So he say that what Ian would say is correct. So yeah, that's a good question. Something I also would like to know more about. And yeah, Philip, stage is yours.
Thank you. Sorry about the technical difficulties. Let's see if we can get this working now.
No worries. Had so many different technical difficulties today.
Let's see.
I believe if Restream freezes for you, you can just wait it out and it will come back.
Yeah, it has frozen.
That's all right. We can see you, we can hear you, and we can see your screen.
Oh, that's great.
Yeah.
So my name is Philip Jonsson. I'm infrastructure architect at PostNord Skålfoss. I'm going to start off with just saying who we are. So we are part of a PostNord group, which is the postal services in Sweden and Denmark primarily. So we're co-owned by the Swedish and Danish governments. But PostNord Skålfoss is its own company, which is similar in organizational structure as one of the countries within PostNord. So we're independent kind of on our own, and we do most of the stuff regarding IT on our own. So we're not really connected that much to PostNord IT. We're present in the Nordic countries, except for Iceland. And we have around 700 employees. Interesting fact around that is that we have around the double amount of virtual machines that we are employees, which means that we're quite tech heavy. So what do? We are doing omnichannel communications, which means that we have customers that want to send communications to their customer. So they send that to us, and we help them spread that through different channels to their end customers. So that can be like physical. We print out stuff, envelope it, send it through the postal services to our customer's customer, or it can be digital services. So we send messages to digital mailboxes, such. I am going to talk about GitOps today, of course. I'm going to start off talking a bit about our journey together with Red Hat, talk a bit about how we are doing GitOps today, and some challenges that we have been facing. This is our current state, and we're still pretty much in the beginning of our journey, so things might still change. And we saw some of the great things that are coming in Argo CD, among other things, which will certainly help us going forward with this. So bear in mind that there are a lot of ways to do things around this, and this is how we are doing it right now. Our container adoption journey started off a bit over a year ago, for real, when we had a project together with consultants from Red Hat, which helped us to deploy OpenShift. And one cool thing about that is that we didn't really deploy OpenShift. We built the automation to deploy OpenShift clusters, which means infrastructure as code. Not really only GitOps, but also a lot of work with Ansible. it's kind of like when Elon Musk says that it's not hard to build the cars, it's hard to build the machines that builds the car. And that's kind of the same thing that we try to do, to build good automation to deploy OpenShift clusters. This project was really great to get us started. Some of the good takeaways with this was that we really try to work in iterations to get something basic up and running before we moved on to the next level. Always working with continuous improvements. And it really helped us to get a good technical foundation around OpenShift and containers, because most of the persons involved in this project were new with this technology. We had like a set goal from the start to try to do as much as possible as code. I don't think that any of us believe that we could do it all the way through code, but the end result and where we are now is that almost everything is defined as code, either through Ansible playbooks or through Kubernetes manifest that we deploy through GitOps and Argo CD. I'm going to describe a bit about how we have structured things in our Git repos and how that helps us to do different things in our environment. So we have 3 main repositories that we use from the infrastructure side to deploy both clusters and cluster components, and also the actual application deployments on top of OpenShift. In addition to this, we have development teams that have their own repositories, which contains both application code and Helm charts and deployment manifests and all that stuff. So this focuses on the infrastructure side of things, but it all ties into the other things, which we'll see later. So we have one repository with Helm charts, which is templated platform components for all the cluster configuration within OpenShift. We have a multi-cluster setup where we have 4 clusters at the moment. So these Helm charts helps us configure them. We have an environments repository, which is the actual configurations for the different clusters, which we're using to deploy the platform components. And then we have a deploy repo, which is the actual application components that we are using to tie into what the developers have in their own Git repositories. So the environments and deploy repos, they almost exclusively contains YAML files which is the application type in OpenShift or Kubernetes. So they're Argo applications, basically, among some other things. So when we deploy a new OpenShift cluster, we're using Ansible playbooks, which we deploy through AWX, which is the upstream version of Ansible automation platform, previously Tower. And that does customized UPI cluster install. When the cluster installation is finished, we apply the Argo CD manifests. And that does a few things. We install one instance of Argo CD and configures it. And then we deploy 2 application objects, which are app of apps. Which basically means it is an application which points to a folder in a Git repo which contains other applications. This is the only thing that we apply in a new cluster. So we don't apply any other Kubernetes manifests. We only apply the Argo CD configuration and these app of apps. And then Argo CD takes over and configures the rest for us. So the apps, app of apps, that is what we use for cluster configuration, and that points towards our environments repository. And then we have the deploy app of apps, which looks at the deploy repository and spreads out into two different components, which we're going to look at more in depth. But first off, the apps, app of apps, which contains the cluster deployment, that deploys all the cluster components, and this is two of them, which is the platform GitOps, which is the actual Argo CD instance that we use to configure the cluster. So as you can see, this is the one that we actually deployed earlier through Ansible, but now we're applying the same manifests with Argo itself. So it takes over management of itself. And this looks towards our charts repository, which contains all the configuration. We also deploy another separate instance of Argo CD, which we are using for the actual application deployments, which we call developer GitOps. So these have some different permissions levels. In the platform GitOps, we can deploy everything, but the repositories which it looks at is only managed by the infrastructure team. The developer GitOps, it can only deploy certain kinds of objects within Kubernetes, which help us maintain more control over our environment. So going to go back to this picture and look a bit more at the lower right part, which is the application deployment. So we have spread this out into two separate app of apps. That is basically because when we have an application project that gets its own project in OpenShift, which basically is a namespace, they need few different objects. So in the platform GitOps, we managed the things that we want to be in place in all the namespaces, and that we don't want the developers to change by themselves. So that contains the RBAC app project in Argo, quotas and limits, and also network policies. So the developers, they can make a merge request to these folders in the repository, but they cannot approve the merges. Someone from the infrastructure team needs to do that. So that helps us maintain control of the environment. And then we have the apps, app of apps, that is deployed into the developer GitOps. And there we deploy all the app of apps for the actual applications that we want to deploy into OpenShift. So these folders in the repository, the developers, application teams, they can approve the merged requests on their own. So what this entire model basically gives us is the possibility to deploy the entire clusters in OpenShift with all required components. And that is our view on disaster recovery as well. Because if something happens to our cluster, we know that we have the entire definition within Git. We have the Ansible playbooks to deploy the cluster, and we have all the manifests to deploy the cluster configuration and applications in Git to be deployed with Argo. So the only thing that we need to do on top of that is to handle persistent storage, which we can do through backup and recovery of that. So that is today is handled outside of this, but it is something that the only thing that we need to consider outside of this. I'm going to show one of the challenges that we might have when configuring OpenShift through GitOps. It kind of has to do with templating, because when we do GitOps, everything comes down to templating in one way or another. We want to handle secrets in some way, and Harriet mentioned that as well in her topics. We're using HashiCorp Vault. And as I said, it's all about templating because, of course, it is possible to store secrets in Git, but you should never do that because it's not safe. So what we're using today is the external secrets operator, which helps us create the secret objects within OpenShift from something that exists within HashiCorp Vault. Some of the components within OpenShift, like some built-in components, they can be a bit hard to configure this way because they might be built for configuring through the console, or they might be built in a way that makes it hard to template. So I'm going to show an example of that, which is the alert manager config within the OpenShift monitoring stack. So this is basically the default config for alert manager, which we're using to send monitoring alerts outside of the OpenShift platform. It can be to a Slack channel or Teams channel or a specific tool like Ops Genie. So the entire configuration for Alert Manager is stored in a secret in OpenShift. And yeah, there are some things that you want to put in this file or this object that might be secret, actually secret, which could be API keys for connecting to Slack or Ops Genie. But the rest of this, that's not really secret. It's just configuration, which could be stored in a config map instead. So what we have done in our environment is to use the templating engine in external secrets to combine these technologies together. So we have our alert manager config within a config map, and then we have templated it, and we're adding on information from Vault, which works really well. The only challenge with that is that we end up with 3 levels of templating. We first have the Helm templating, which helps us to deploy everything into the cluster. We have the external secrets templating, and then we have templating within Alert Manager, which helps us deploy or template the messages that we send to the different alerting platforms. And the bad thing with this is that they all use the same syntax as well. So that can be a challenge, but we have managed to get everything working, which is really nice. I'm sure there are a lot more challenges, but I just wanted to show you this. And I think that we need to get going as we're a bit behind time. So thank you for listening.
Wonderful. Thank you so much, Philip. That was fantastic.
Thank you.
If anyone's got any further questions for Philip, please do pop them in the chat and we can pass them on to him.
Yeah, I'll stay behind and answer some questions in the chat.
Brilliant. Thank you so much.
Thank you.
All right. Next, we've got Richard and Misho from Arbets for Medlingen. So over to you, Richard and Misho.
Thank you. So what we will talk about is Arbetsförmedlingen, or the Swedish Public Employment Agency's experience with GitOps on OpenShift. So both Misho and I, we are working within the DevOps team here at Arbetsförmedlingen.
Hope you can see our screen.
Yes, looks great.
Can we? Yeah. Nästa slide. So our journey with OpenShift began really in 2018 with a minimum valuable product, and which turned out to be successful. And we continued with an OpenShift 3 cluster in 2019. And last year we installed a two OpenShift 4 cluster. Our development organization is split over like 50 development teams. We're continually developing about 120 applications. And when we deployed these OpenShift clusters, we took all the applications from our then current legacy environment over into OpenShift using lift and shift. So we're maintaining the basic architecture of our code, which is mainly wide-fly applications for Java and .NET Core applications in the Windows space is about 50-50, and then we have all their front-end applications as well. So in our legacy environment, we had basically no DevOps culture. We had operations managing production, old school virtual machines. Developers could not didn't have any access to maintain their infrastructure, and they expected lots of support. So our legacy environments, we relied heavily on Jenkins continuous integration application with Jenkins pipelines, and we retained that in the OpenShift 3 cluster. So we installed Jenkins instances per team within the cluster, and we also provided pipelines for development teams, both for building code and performing imperative deployments. And we ran into problems. Developers found it hard to find what version we're in prod and knowing status overall. And it turned out that the Jenkins within the cluster was very, very resource intensive. So we had to dedicate several worker nodes to only execute Jenkins masters and agents. And also developers, they still expected lots of support with regards to Jenkins administration and maintaining pipelines and stuff like that. So we didn't really achieve any team ownership of the CI/CD tools and process. Let's see, nästa där. Then we had to do something, and we had a very inspired developer that said, we want to try this Argo CD. So we did that in a small scale. We still retained Jenkins for build application and images, And then from there, we increased slowly and extended the number of applications deployed with Argo CD. And we almost immediately found out it was very stable, and we could achieve automated deploys, easy rollbacks, and we got the desired state in declarative in Git. Initially, we had a little bit of learning curve in the administration of Argo CD and how the application and process should work. Last year, we deployed our OpenShift 4 cluster, and within that, the GitOps is enforced. And we have several Argo CD or OpenShift GitOps instances, one for infrastructure and one for the application space. And that goes both for test and production clusters. Sorry, now we should
maybe
switch over here to Mishu.
Thanks, Rickard. And this is last year, like Rickard said, we implement OpenShift 4. And originally, we planned in Q1 and Q2 at migrate all our customers from 3 to 4. But because of the lack of hardware and the long lead times for hardware last year, we are doing it that now. But we had a few differences with the 4 implementations because now we are enforcing to use GitOps and Argo CD, and also we wanted to get rid of Jenkins, and not everybody was happy, especially not the developers which have been using it for ages. But then we introduced Tekton, or the OpenShift pipelines, which was, as you know, Kubernetes native tool to do the build process or the CI. And then we are using templating with Customize and Helm. And with that, we noticed that we have enabled the DevOps culture in a way, because now most of the teams, after getting the hang of it, of the new tools that we introduced, they started to doing all the DevOps stuff themselves, which was a little bit of a problem in the OpenShift 3 implementations, because those teams that didn't have the knowledge and didn't have the time or the resources to do the build and deploy process, then we did it for them. But then we ended up like not transferring any knowledge to them. So, but with this approach in the 4, we transferred most, and they achieved like a DevOps culture in the organization, which we are really happy about. One of the pros of this approach is because it was a rapid acceptance of the GitOps. After we saw that it works, so all the teams wanted to get in on it. So it was really good. And then from the teams, we acknowledge like a huge drop in the support issues they had previously in the deploy part, in the deployments. And as I mentioned, we have no Jenkins, and we are so happy about it, because then we can use our resources much smarter and not to dedicate worker nodes just for Jenkins and not to spend any time for it. But on a cons part, we had to learn a little bit more about how to administer Argo CD better, and we had to learn also how Tekton works, and we had some work done in the performance of it as well. So another interesting thing that we introduced is like in-house self-service portal. That is a portal that we created where a customer, like a product owner of a development team, can come into the portal, and with few clicks he can order can create his own project or namespace in the OpenShift cluster. And beside the project, we create the groups, we create the roles, the role bindings, we create the quotas, the limits, the projects, and most importantly, the Argo CD back. And then all those manifests that we create, they are automatically synced using Argo CD, which was really interesting for the teams, because they didn't have to wait for us to order a namespace, or so everything happened automatically, and they can just start working and building their pipelines and building the applications and starting deploying it. The pros of this approach is self-service, it's a minimal support, and it's really automated the bootstrapping or the beginning of the usage of the platform. And there is a cost of this, and we have to maintain the portal. For now, it's a small portal that does just this that I mentioned, but in the future, we plan to develop it and to have it as our platform, to have as a PaaS solution for our platform, and to have more and more services that can be automated and built into the portal. But we must say we are not 100% GitOps, because some of the manifests we require for the developers to create them through the Argo CD UI, and that's the project scope to repositories and the Argo CD application itself. So that's why we are looking at the next steps to evaluate the concepts like app of apps, application sets, and the GitOps application manager as well. So in conclusion, what we like about the GitOps is like everything is in Git, and we can deploy any Git commit, whether was it in the past or we can go back and forward in time. And automation, we can automate the deploy process, and we have support for Helm and customize. And the most important for us was that the team owns now the process, and the team takes full responsibility for the build and the deploy process. And we have less support for the teams. So that was it, and maybe the questions we can take in the AMA at the end, or yeah.
Wonderful. Thank you so much, Misha and Richard. That was great. Yes. We've had folks asking for the link of the video when it's done, and I believe we'll be sharing folks' slides as well if they're available too. All right, so I will be handing over to Thomas and Manuel from Swiss Federal Railways. Over to you both.
We can't hear you.
I'm sorry, missed the mute button. So, hello from Switzerland. We're trying to give you a little introduction in our project called TechTalk. It's just another CI/CD system that we have developed for our internal use. So, who we are? It's Manuel Walrapp and myself. We're both software engineers at the Swiss Federal Railway Company, in short SBB. And along with the entire ESTA team, we have developed this TechTalk system over the past 2 years. So ESTA is not in any way related to the US immigration system. It's just an acronym from our internal team. It employs 10 engineers from juniors to seniors, and also 2 trainees. And as already mentioned, we're working for the Swiss Federal Railway Company, which is hopefully known for running trains on time. And a less known fact about SBB is that we have a notable IT department, which is developing and operating a lot of custom software products that help operate the trains and basically the entire company. So we're talking about approximately 1,800 software projects, and we meanwhile count around 40K Git repositories in our Bitbucket system. We're running OpenShift in a large scale. We have 43 OpenShift clusters currently running on different cloud platforms, private and public clouds, with a sum of 40K pods running constantly. So, and this is where CI/CD also plays an important role in everyday life of our IT engineers. And of course, GitOps is a key strategy in SBB IT2. It has been for some years, and it's continuing to become more and more important. All right, so what is SD Tecton exactly? To put it in one phrase, I would say it's a highly opinionated CI/CD system that we have built on top of OpenShift pipelines. So our goal was to create a scalable CI/CD service that was specifically tailored to the software development stacks and workflows that we use at SBB IT. It should have a simple ramp up for existing and new projects. And of course, we wanted to get rid of the Jenkins instances that we're still having in production. Let's have a look at some key facts about this SD Tecton system. It implements standardized workflows with predefined pipelines that we have built and put together, but it is yet extensible and customizable for those projects and teams that somehow can't stick with these very strict standardized workflows. It is easy to use, so we try to hide away the complexity of Tecton and also to lower the learning curve for the development teams. So in order to put your software project on the CI/CD system, you have one single JSON-based or YAML-based configuration file that you put in your Git repo, and you're ready to go. It is fully integrated into the services and systems that are in place at SBB IT, which is Bitbucket for source code management. We use Artifactory for all sorts of artifacts to store. We have SonarQube in place, and we use Microsoft Active Directory and login for authentication and authorization stuff. We wanted to provide a simplified user interaction specifically made for software developers. So they don't look at the OpenShift console necessarily. We will see later in the demo how this looks like. The system is scalable because it runs on OpenShift on different platforms. We have auto-scaling machine sets configured in the background that will scale up machines when there is a build load coming up and scale them down overnight to save some costs. And we implemented the least privilege principle in a way that each instance of SD Tecton is isolated and only has the credentials that are absolutely necessary to build the project, but not more. So let me give you a little overview of the architecture. So the gray box in the center, this is the box that's SD Tecton. We have several components in there that we have developed ourselves. The Tecton controller is the backend application. We have the control panel, that's the front end, the UI that renders in the browser. We have a set of pipeline templates that are being used to run all the tasks. We have secrets management in there, and also some caching facilities to speed up build performance. This all connects to Git repositories, consuming information from there, and eventually also writing back some changes. The build pipeline produces Docker images or other artifacts that are put on Artifactory. And for the development part, we're connecting to Argo CD, which sits on in most cases on a different cluster where the production applications are running, and Argo CD is managing the deployment there. So the typical workflow for a software project build looks like this. It starts either with a push to a Git repository, that can be a push on a branch, or by creating a tag. Another way is user interaction through the Tekton control panel, where a user manually starts build or creates a new release. The controller then reads this configuration file from the repo and takes according actions. In case of releasing process that was started by the user, it will start a so-called tagging pipeline. As the name suggests, this basically creates a tag in Git after updating some version strings in repository files. This then again triggers the build, where the actual build process is started, which usually ends in some artifacts, mostly Docker images, being pushed to Artifactory. And if staging is configured for this build pipeline, we will start a third type of pipeline doing the staging. That means it will update a version string in another Git repository, which is connected to Argo CD, and it will then trigger Argo CD to do the sync and to actually update the deployment with the just built version. So we have created predefined pipelines for different development stacks that are mostly used at SBB IT for projects. So we can build Java Maven projects, NPM-based projects, Go software, plain Docker builds. We also can use build packs for do the building part. Can release Helm chart, build Python pipelines, and the latest addition was to support Flutter applications to be built with this system. All right, so let's have a look how this actually looks on the user side. And for this, I'm handing over to Manuel to give you a little demo. Thank you.
Yes, exactly. I take over the sharing. I don't know if you can see it already.
All good?
Okay. Can you hear me? Somehow something crashed.
Yes. So, okay, I can hear you.
You can hear me. Okay. I try to share again. When I shared, it crashed.
So I have the screen from Thomas open by yourself. Okay. Now I have your screen sharing, but it's this window. Maybe you have to select another tab or window.
Yes, yes.
Right on.
You see it?
Yes. Right.
Okay. So exactly. So I would like to show you a little bit how this looks in practice. And for that, I would like to show you a simple continuous integration build where a user will push something to the Git repository. This will create an event which will notify over a webhook the Tekton controller. and the ESTA Tecton controller will start the build pipeline. The build pipeline will report back the build status to Bitbucket, so we can see in Bitbucket also how the build is performing. As you see, we don't use ESTA Tecton trigger tasks, so we replace that with our own implementation. Exactly. I have here the screen of our own build namespace. We have around 60 build namespaces. So each project team has its own build namespace, which they can order over a self-service portal. So it's kind of the whole Tecton build namespace setup is optimized. I made here a little Tecton demo project. This is the view where we can see the Bitbucket projects. So not the repository view, and it is the project view. Each project contains several repositories, which we can see here. Our project contains one repository which contains the ESTA Tecton pipeline JSON, which then steers the whole build. We see here also the last pipeline runs, like a build pipeline or tagging pipeline. What we didn't implement here is a staging pipeline for this demo, because that would, we don't have enough time to show everything. This is the detailed view of the repository with the different branches. So we have here a master branch and a feature branch where we can start a build. First, I want to show you fast how this looks in the Bitbucket repository. Here we have the source code and the Helm chart, POM XML, and this one is the magic file, the ESTA Tecton pipeline JSON. Can also be a YAML file, we support both. In here, we define first the technology we want with the details that we want the Docker build. Here we can also specify a Docker file, or we generate automatically a Docker file for you, which is in most cases done with SBB. Then we can define a Helm chart and then the different pipelines. So we have here a continuous pipeline and we have a release pipeline defined. This is triggered, the continuous pipeline is triggered by either by user over the UI or by a Git event from the Bitbucket repository. And it is the triggers are filtered for this branch name prefixes, master, feature, or hotfix. So your branch needs to be named like this. And if you do a push on this branch, a build will start, a continuous build will start. I show you fast how that looks like. We have here the project. I'm gonna just change the README. I commit that. I push it. And this push generates an event, and we see already a pipeline started. I didn't refresh anything. The UI gets notified automatically. And here we can see now the continuous build. In the details of the continuous build, we can see that we have tasks which are running, where happens a Git clone, there will be a Maven cache load. Then we have a tab where we have all the logs. You can filter the logs by the different tasks. We have the same for the events, because we are also streaming all the events live. Then we have a tab where we have all the details, where you can see why was this pipeline triggered with the actor, revision, and so on. And the pipeline configuration, effectively which pipeline was triggered. And then we see also, yeah, okay, we want to build, or we don't want to build a Docker image, we want to deploy it or not. We want to deploy the Maven artifacts, and so on. And in the end of the pipeline will publish results. In case there were some Docker images, you would have here the link to the Docker images. For debugging purposes, you can also look at the parameters, which are the effective parameter for the pipeline template. Of course, we can also see the original pipeline run, which is pure Tekton. It's nothing else. Most of you who had contacted Tekton know this. And this is all we do. We have straightforward Tekton pipeline templates, which we modify over Java API if necessary. We have also the option to inject tasks. So if you see here, we have the Maven build, we have Sonar Scan, we have OWASP Scan, and so on. And if you need, you can also inject your own custom task here. Exactly. This was a short example of how we build a continuous build by a Git push. Now I want to show you another workflow. This is the release process. The release process looks a little bit different. A user goes to the Tekton UI and creates a new release, which I will show you. The Tekton controller, it will start a tagging pipeline. The tagging pipeline will modify, for example, the POM XML and the Helm chart in the Bitbucket repository, which creates, again, over a webhook, a notification to the controller. The controller looks, do I have for this notification a matching pipeline? If yes, then it starts the matching build pipeline, the release pipeline in our case. Once the release pipeline is finished, the Docker image is published to the Docker registry. In our case, it's Artifactory. An email is sent to your email server, and in our case, we use Microsoft Teams. Also there we have notifications to a Teams channel. Once the build pipeline is finished, a staging pipeline starts, if you have configured it. The staging pipeline can, for example, modify in a foreign repository a version in a Helm chart, for example, in an Argo CD repository. And then, if necessary, trigger in Argo CD the application sync. Or Argo CD can also listen to webhooks, so you don't need to trigger the application sync. That's part of how you want to set up the whole staging process. Okay, I will show you fast how that looks like. It's also pretty straightforward. I can go here and click the tag. I can select, it already proposes me the next tag. At the moment, we have a 005 snapshot version in the POM XML. Then I select the 005 and say, as the next release version, and say the next developer version should be 006 snapshot. I click next. It tells me what it all does, all the single steps that it applies to the 005 to POM XML, commit these changes to master, create a tag, then apply the 006 snapshot to the POM, and commit all these changes and push everything to the Bitbucket repository. We execute that. That starts a tagging pipeline, which is fairly simple. I can also show you, you don't see much. It's only one simple task, which does the whole tagging and the modification of the information in the POM XML and the Helm chart. And if you go back here, we'll see already, you see it's like instant. The new pipeline has already started. There was an event created from Bitbucket that it was modified, and the release pipeline was started. It was this one here, the release pipeline, which listens to a Git event, and it filters for a version tag event pattern with this regular expression. So if a tag event from Bitbucket comes, which has a version in it, which matches this regular expression, the following build is started. And here, of course, you build a Docker image. Then I don't know how we are in time. Maybe I can also show fast. We have here also some migration helps from our old pipeline from Jenkins to Tekton, which speeds up the migration. Of course, we have user permission UI. You can edit pipeline secrets. The secrets, they will be injected into the tasks. So if you have custom tasks, you have these secrets available. Then we have here the credentials you can edit. And very important, we have here the ESTA Tekton pipeline templates. This is our Bitbucket repository where we have our custom pipelines. They're developed by us. Therefore, the whole SOP the same and our own tasks. We also build our own builder images. So each of these tasks, or most of them, they use our own builder images with the specific Java versions you can select and NPM versions and so on. And if you want, or if one team wants, they can overwrite tasks from us or templates from us. So they have a second repository with their custom tasks, or they choose the same name or path to overwrite this pipeline with their own customization. For example, if you have a ESTA Maven tagging task, this is a normal Tekton task. One team, for example, they want to calculate the version over a REST service. So they overwrote this particular ESTA Maven tagging task. Yeah. Exactly. Here we have the whole pipeline view where we see all pipelines. We also have a repository view. I see somebody cleaned up all the pipelines. This was not me. Maybe I can show you a little bit something more, which is not such a Mickey Mouse project. We have here an example from another project where we have 90 Bitbucket repositories. And we see here really a green carpet of builds. So we use this system in production, and so far it scales really well. Yeah, this is more or less what I wanted to show you. I want to give you a fast outlook to the future. Maybe a little bit of background information. The UI is developed with Angular. We have our own Angular library, and the backend is developed in Quarkus. We use mostly Quarkus native. In one case, we use only Quarkus Java because we are not sure about certain stability. Yeah. Then I want to give you a short outlook to the future of ESTA Tekton. We are thinking of introducing pipeline as code if you want to have like for various customized cases where our Tekton system doesn't make sense. So we can also use pipeline as code for our developers. But I think for 80 to 90% of all teams in SUB, our ESTA Tekton system is enough, or they can fully use it. Then we want to integrate test reports in our control panel. We want to also optimize performance and resource usage. And the biggest, maybe could be also interesting for you, is that we plan to make it open source, but there's still a bit of work in front of us because it's opinionated and bound to our systems. And anything else you name. Thank you very much for listening.
Thank you, Manuel.
Yeah?
A bit of an echo.
Yeah, there was an echo. No, still an echo.
You hear me still? Wait, I can maybe change another speaker. Is better?
I think it was on me, but I don't know if he fixed it.
That's all right. We're sorted.
It's better?
Yes. All right. Thank you so much, Manuel. That was fantastic. And thank you, Thomas, even though he's already dropped. Okay, if anyone's got any further questions for Thomas and Manuel, please do pop them in the chat. That'll come through to us all over here. For our final session today, we have got our AMA panel. So apologies for running over time, folks. We will keep this one fairly short as we've been answering your questions in the chat as they've come in. So if you do have any questions for us, please do pop those in the chat. We will do our very best to answer them.
Should we pull everyone now in the stream? So everyone is in. Let's do it. There's Christian.
All right.
There's
Welcome,
Abhishek.
Christian. Welcome, Abhishek.
Misho. Richard. Where's Thomas? Thomas.
There we go.
There we go. Are we missing anyone?
Philip? Did Philip drop off? He might have had to leave.
Yeah.
That's all right. All right. Thanks, everyone, for sticking around. Have we got any unanswered questions that have come through in the chat? Let's have a look.
Well, one question was already answered by Manuel. They were asking if the dashboard was open source. So it looks like it will be open source at some point. That's great to hear.
That's very exciting. All right, who else have we got? Well, we did have a request for a blog from Philip, so hopefully we do get that sometime in the future. That would be wonderful. I'm sure everyone would be very interested in blogs from the rest of you as well, Misha and Richard and Manuel and Thomas.
Yep.
All right, while we're waiting for any last minute questions, I actually have a question to start with, if that's all right. I will just jump to the head of the queue. So my question's for Christian. We got to see like a little taster of ACM policies when I was demoing the validated patterns earlier. Are there any kind of like specific policies or types of policies that you'd recommend folks to try out first?
Thank you, Harry. This is a good question. So we have a policy collection repository, which I will send the link into the chat. And here you will find lots of examples which can be basically used without any modifications. And the customers are looking into these examples and they are looking what is fitting for their needs. So usually they are doing a fork of the repository, and when they are deleting some policies which we don't need, and when we are applying it, usually in a GitOps style. So ACM uses its own GitOps implementation, but you can also apply the policies with Argo CD. So this is what many customers are doing. So we had just this call today with a customer, and he mentioned he is looking mostly into security-related policies. So for example, like EDCD encryption, ensuring that the kube admin has been deleted for some managed clusters, which is a valid use case. So to give you a short answer, security is the #1 focus, but we have also much more regarding configuration management, regarding monitoring of certain resources. So I really recommend you to take a look into this repository.
Awesome, thank you so much. It looks like we have another question for you from the chat. Do you have any good examples or recommendations for application deployment through ACM?
Yeah. So you have given a very good overview about how to do it with GitOps operator, and certainly ACM can also serve as a control plane for deploying applications. So as you have mentioned, in the same way, there are different patterns, and this highly depends on the customer need. So there might be customers who really like to have Argo CD on every managed cluster in the fleet, so a decentralized approach. But we also support tighter integration like application sets from the UI, where we are leveraging our placement UI, which is basically responsible for deploying the applications to different clusters. And you can certainly also just use a managed cluster, as you have shown, and import it into the Argo CD UI, so that you can just deploy also to different clusters this way. So one highlight, what we are working on, is the application set pull model approach. So as you know, at the moment, application sets and also Argo CD is using a push model. This means you are deploying a GitOps operator on a cluster, and it needs to connect to the managed clusters. There are some use cases, some customers who like to have the opposite, so they don't like this direct communication. And this is something we are implementing. We are active in the community, where we are discussing this new design. And if you are interested in this new feature, I would be very happy to talk with you about.
Awesome. Thanks, Christian. All right. Any practical examples or blog posts that you might be able to share with the stream? We could pop some links in. All right. And another question. Is ACM suitable for UPI? Can I use this setup to create additional clusters with UPI elements and achieve the same result?
Yeah.
I know this was targeted at me, but Christian's going to be the better one to answer that.
Oh, Harriet, please feel free to answer the question. So, so many customers have their own way to create OpenShift or Kubernetes clusters. Many are still using Ansible, Terraform, whatever. And certainly ACM has the option, as you have shown before, to import those clusters which have not been created via API. And basically, there is no limitation of managing this kind of clusters. The only thing maybe is that you can't destroy clusters from ACM which are imported. No? You can just detach them again so that they are not managed anymore with ACM. But apart from this, there is no change regarding the ability to manage those clusters created via UPI.
Excellent. Thank you so much, Christian. I do have another sneaky question, if that's all right. This one's for Abhishek. So I know you are quite involved with the Argo CD upstream community. If anyone was interested in getting involved with that, how would they go about it? What do they need to do?
Awesome. Yeah. So if somebody wants to start with the Argo CD community, then yeah, you are up for the best community, because the community hosts every week contributors meetings where people can join the meetings. It's open for everyone. They are all CNCF meetings. Everything is available on the GitHub repo, the meeting links, agenda, all the things. One is you can start that way, joining the meetings and understanding the status of the project. The other thing that you can do is, again, the project is very well organized. We have a lot of triagers who up to date provide the labels on the GitHub issues good first time, or you have labels where you can start up with Argo CD. So yeah, this is something like, go to the GitHub repository, look for the startup issues, good first time, you can start with there. Or let's say you're not probably you don't want to start with the issues, then you can also go there and join the community meetings.
Very cool. Well, hopefully we see some new faces around the community meetings from folks from the stream. That would be very cool. All right, I think we have run about 10 minutes over. Should we try and close things off there? Natalia, is that all right with you?
Yeah. I think we had a really great DevNation TechTalk today. I really enjoyed the live demos, all the showcase, the customer use case, and all the products you are building in-house. It was a really great stories. And the cool thing is that everything is already recorded, and the recording is available already on YouTube and Twitch. So you can use this the same link to watch the recording. And Oriet, I think we can give to the people attending this link, which is the new OpenShift GitOps landing page. Thanks to our colleague that made up this page so nicely. You find all the information, like what Oriet was saying, the labs links, the books links, all information about OpenShift GitOps, and connection to Red Hat products. But I'm happy. What do you think about?
Yeah, it's a fantastic session. The usual little bit of gremlins, which is always entertaining, especially from behind the scenes.
It's not a live show without gremlins.
It's a fantastic concept, and it's a fantastic set of technologies. I see it becoming very, very big over the next 3-6 months, especially around the inclusion of Tekton as well as Argo CD. So, yeah, I thought it's been really, really, really cool. It's also nice to see the customers using it. That's the big thing for me. Because it is a pragmatic technology. So thanks for all the customers actually attending today. I found it very entertaining and interesting. Natalia?
I'm looking forward to see what's next in your internal portal that you're building, what's in your next experiment, your next multi-cloud experiment with, I don't know, maybe you can combine ACM and make other multi-cluster strategies. What I've seen today, it's really, really cool. Looking forward to see what's next for that. And with that, thank you all for joining our DevNation Tech Talk. Thank you, Hored, for being great host, presenter, live demo, entertainment, everything. It was literally great. Thank you, Misho, Richard, Thomas, Manuel, Philip, Christian. So great stuff today. See you soon here at DevNation.